Back to the Astro Imaging channel. Glad you can make it, and you've adapted to our twice a month schedule, which is nice. Tonight we have Jon Talbot that's going to talk about, well, he's going to tell you imaging, catastrophic. What is that, John? I've forgotten.
Cataclysmic variable stars. Nebula. Yeah.
And,
can't even say the name of our talk for our guest tonight. Come on.
I can't even say it, and I'm involved in the project too. But you know, that's normal. At least I can produce images. And before we get going on that, I'm going to share my screen just to go over our schedule. So let's see, share screen, entire screen, and share. And once again, we're on a twice a month schedule. Tonight we have John. 2 weeks we have John Nebulae and Kyle Goodwin, and we're going to get a kind of an elevator pitch on that show in a little bit, but it's about Murphy's Law in your telescope. And in the last half hour, we've all been sharing our failings in operating a telescope, and Jeff's going to give a presentation on that. 2 weeks after that, Gary M. is going to talk about imaging the complete sharpless catalog. And if you don't know Gary, he has more images on AstroBin, I think, almost than anyone. And he is more like than anyone. He has his great catalog. If you want to download it, you should go to Gary's site on AstroBin and look through it. And he's going to talk about the sharpless catalog. No show on Thanksgiving. And then Mike Cranfield is going to be here on December 7th. I'm sure Mike's going to have an interesting presentation. And by the way, if you haven't gone to his site, I think it's Cosmic Photons, he has this great PixInsight script about generating HR diagrams. And if you don't know what those are and you image globular clusters, you should go look at that too. And in the 21st, Brian's going to be here with no show on Christmas. And as you see from the calendar, we have lots of open dates in January. So if you have an idea for a show, go to our site, theastroimagingchannel.org, go to the contact button on top, and give us a note and tell us what you'd like to present. Someone will get back to you, and you could probably be on the show. Now, before we get into John, I think, Jeff, you're here. You want to give us kind of a introduction to your presentation?
Absolutely. Thank you. So I'll be co-presenting a talk on observatory safety automation with my friend Kyle Goodwin. Kyle and I originally met when we just happened to build remote observatories right next to one another at Deer Lick Astronomy Village in Georgia. Because we built our observatories at the exact same time, we faced and solved a lot of the same challenges at the same time, which allowed us to put both our heads together to solve problems and bounce ideas off of one another. So a year and a half later, we both have remote observatories that open every clear night, collect photons, close and reopen reliably in emergency situations, and then close automatically when the sun rises. We've both added a number of layers of safety redundancy, as well as what I call self-resolving capabilities and components that reduce as much as possible and help the astrophotographer sleep peacefully through the night, even when you know a storm is forecast to roll in at about 3 in the morning. So during our talk, we will discuss many of these safety systems, the hardware, the software, the logic, and the layers of redundancy and self-recovery. So we're looking forward to sharing all this to help everybody else sleep better as well.
Okay, thanks much, Jeff. And now John going to talk about Nebula around cataclysmic variables.
All right, well, great. Well, thanks, Eric. And thanks for having me on the show tonight. And let me see if I can share my screen and do this the right way. Whoop. All right, where are we here?
We're at the infinity screen, our favorite.
You can just minimize the browser there.
How come we're at the infinity screen? All right. How's that? Can everybody see that?
Yeah, that's good.
Okay, great.
Perfect.
Again, yeah, thanks for having me on tonight. And So this is really a story. It's kind of a story of how I got into working with some professional astronomers, and it's a story about other amateurs joining that quest to image some of these really faint nebula that are around these stars called cataclysmic variable stars, and the resulting papers that have been written from those images. And it's kind of a story of, you know, if you're an amateur astrophotographer, like the majority of the people watching the Astro Imaging channel are, well, you know, this is a way, these are things that you can actually do and to help the professional astronomy community. And when I retired from my regular job about 9 years ago, I thought, well, what can I do to you know, help the professional community? And I thought long and hard about that, and you know, and I think I probably told part of this story on a previous episode of the Astro Imaging channel, but I thought, you know what, I bet you if I can shoot and image these very faint nebula, and I can do that from home, that gives me a huge advantage, right? Because where do I have a lot of time? I have a lot of time at home, and whether I have a portable setup in my backyard, or you know, a observatory in my backyard, you know, there's lots of ways that people can do this. So this is kind of a story about that. And what you're seeing on the screen right now are 3 images of these nebula that happen to be around these special stars called cataclysmic variable stars that we have discovered over the last couple of years with the help of professional astronomers. And we've had some really interesting professional papers written on these. And these are, you know, things that you typically don't see. So, you know, again, why would I want to do this? Well, you know, I've shot a lot of things in the sky. I've spent over 20 years doing astrophotography, and you know, I really didn't want to do M31 again or M13 again. I wanted to do something different, and I wanted a kind of a different challenge. And you know, so maybe, you know, the listener out there, maybe you're interested in doing something like this too. Maybe you're interested in helping discover, you know, different and new objects. And what a lot of people don't realize, you know, looking at this image here, this is just the bubble nebula, right? This is, everybody has shot probably the bubble nebula at least once or twice. Well, did you really know that there's a planetary nebula there? And it's this one here. It's called KJPN8, and it's really close to the bubble. It's up in the just above it and off to the west a little bit of it. And yeah, I thought that was kind of interesting when I first realized that, when I started digging into an image to see, well, what else is in this image other than just the typical object that you normally look at. So yeah, this was one of those things of, you know, maybe I can really do something different. Maybe I can help out the community in some form or fashion. Well, that happened actually in 2021. Well, actually, it was in 2019 where I first imaged this really interesting old ancient planetary nebula, and it was called ALV-KN1 FR225. And you may have heard me talk about this before, but the way that they name these nebula, so up on the top of the screen, the FR stands for Dr. David Frew, and this was an object that he discovered. But it was also discovered by some amateurs named Philippe Alves and Matthias Kronenberger. And it was also given the name of ALV for Alves and Kronenberger, KN. And this was the first object. So anyways, the point is, this was a very faint, ancient planetary nebula. And here I am sitting in my backyard, and I thought, you know what? I wonder if I can actually get an image of this thing from my Bortle 5 to Bortle 6 sky. Depending upon the night, I used to be able to actually see the Milky Way from my backyard. Not so much anymore. I'm more leaning towards the Bortle 6 now than the Bortle 5, but it goes back and forth. So I thought, maybe I can shoot this. So I tried this, and I put about 20 hours into this, and there it is. I was able to actually do this from home with the light pollution, the sky gradients, and everything else. I've got casinos 10 miles to my west. I've got Naval Shipyard in Chevron refinery just to my east, about 10 miles. So I've got quite a bit of light. And if you look at one of the light charts that shows, light pollution, you'll find right along the Gulf Coast where I am, there's quite a bit of light. It's not anything close to what it's like west of the Mississippi River. So this image was actually seen by my friend Saqib Rasool in the UK. And his first question, I didn't really know him very well then, but his first question was, well, how did you find this thing? And I said, well, I was searching the internet one day, and I wanted something hard. I wanted something different. I wanted something that gave me a challenge. And I came across this listing of this planetary nebula and thought I'd try it. Well, he then asked me, he goes, you know what? He goes, I have a list, or I can provide you with a list of a lot of relatively unknown objects. And it ended up being hundreds of them. And I gratefully, accepted his list and said, you know what? That is really cool. Yeah, I will take that, and I'm going to try to image some of this stuff. So he passed me his list. And the first one I tried was this object called FR2-30, which was in Andromeda. It's up there right now. This is a good time of the year for it. It was listed as a potential planetary nebula. And it had several different designations. You can see one of them was the typical PNG type designation, which you can find on Sinbad. If you type that in and you do a Sinbad search, you'll come up with the object. It fit my field of view right, and I thought, you know what, I'm going to give this a try. So I shot this. I spent about 28 hours on this of just HHA-03, and put some time into the RGB and put together this image you see here, which was kind of like an HOO image. It's got RGB stars. Hydrogen was mapped to red, and oxygen 3 was mapped to the blue-teal color, blue-green color. And this happened to get the attention of a professional astronomer named Dr. Howard Bond at Penn State University. He'd also worked at the Space Telescope Science Institute. And this is the same Bond that is in, if you're familiar with some of the objects like EGB6, which was named after Ellison, Gray, and Bond. It was a planetary nebula that they discovered. This is the same Dr. Howard Bond. And he just happened to see this image online because he had actually imaged this at Kitt Peak and taken spectra on this. And he got a hold of me out of the blue, probably 6 months or a year after I had published this on my website or maybe on Astrobin. And he said, how did you find this? And I said, well, I got a list of these really unknown objects from a friend who happens to live in the UK. And he said, you know what? We took spectra on this object. How would you like, or would you let us use this image in a paper that we're going to write about this object? And, if you'd like, you could be a co-author of the paper. And I thought, darn, what amateur astrophotographer would turn down something like that? And I said, absolutely, you guys can use it. Well, that started a relationship. And that relationship has, been fostered over the years to today. But this was the first image that got that going, is because I decided to go after something that was really, really faint, something that was really hard. And it got the notice of somebody out there in the, a professional in astronomy. So I guess my point would be, if you want to do something similar to what what we're doing, this would be one of the ways to do it. Go after something that's really, really hard, and prove that you can actually do it. And this image was taken from my home. This was from my backyard. This is a Bortle 5 to 6 sky image, and it's the first color image that was ever produced on this object. So yeah, that's what I would do. I would go after something real, real hard, which is what I did. So this was published in the monthly notices of the Royal Astronomical Society. And here's just a couple, screenshots of the paper. But it was kind of a proud moment for me anyways, because I thought, you know what, now I think I'm getting close to that goal of maybe being able to help the professional community do something, or figure out, in this case, what this object really is. And as it turns out, it probably isn't a planetary nebula. It just happens to be a bunch of ionized oxygen and hydrogen with a star that's moving through an area that happens to have this gas. But anyways, they would not have known that unless I think I helped them by providing the color image. So yeah, so that was number one. That was the first one. So what about these cataclysmic variable stars? Well, there was a piece on the YouTube write-up, but cataclysmic variable stars basically are stars that are kind of a binary type system, where you have a white dwarf and typically another low mass type star, and they orbit each other. And typically the ones that I'm going to talk about are on the order of like hours versus days or weeks. But these are these stars, the companion star typically is throwing out mass towards the white dwarf. The white dwarf is like sucking up the hydrogen from the companion star via this accretion disk. And these stars typically undergo brightness changes. Sometimes they go through these explosive events, like a nova type event or a dwarf novae type event, due to this accreting material. If it decides that it's reached a critical mass and it goes off. The stars that we're going to look at, though, belong to these what's called an NLV type subclass of these CV type stars, and yeah, they contain a few surprises. So starting off with these, we'll look at this one called SY Cancri. This is it varies in magnitude from 10.5 to 14.5 magnitude. It's in Cancer. Its brightness varies over a period of about a month. The AAVSO has this listed as a peculiar dwarf nova plus a G8 type primary. So you have in this case, you have a white dwarf and a G8 type star, which is the low mass one that's accreting the material. And this nebula was actually already known. It was known as PAEL1. It was actually discovered by another friend of mine, Dana Patrick, and David Elmore back in 2022. Dana is a well-known amateur that has discovered loads and loads of planetary nebula and other types of objects. So he actually found this, and by looking at survey plates, he actually saw the emission and thought maybe it's a planetary nebula. So Dave Elmore imaged this area with his little refractor back in 2022 and confirmed that, yeah, there was nebulosity there. So this data was posted to an amateur website, planetarinebulae.net, which I think I've mentioned in the past. And it was given a designation of PAEL1, means Patrick Elmore 1. It's also in the hash Planetary Nebula database, and it got the attention of Dr. Howard Bond, who was a Planetary Nebula guy anyways. You know, he was interested in that. So here is one of the first images of that, and this was taken by my friend Peter Goodhue. Peter's in the UK. He's an amateur astrophotographer. He's got a great setup in Spain, several refractors, and a C14. And he took this in April of 2024 using his 6-inch refractors and C14. And yeah, you can actually see it's got this area of an arcing look to the hydrogen. And it's got some oxygen 3 that's also in there, which is in the bluish color, and it's also in sort of this arc. So he put together this exposure at 34 hours. And I happened to see this, and I looked at my list that I got from Sakib, you know, and I found this nebula in the list. I thought, you know what? I just happened to need something to shoot because I didn't have any target, and I was utilizing a scope that a friend of mine set up that he gives me access to. It's out in West Texas in Fort Davis. It's up on a ridge, which is about as high as McDonald Observatory, and it's a plane wave DR350. And I thought, you know what, I need a target for that scope. So I ended up putting in this target, and I ended up with this image here, which was, again, it's just an HOO type image with RGB stars. And you know, I thought, you know what, let me see what I could do with Peter's nice, beautiful image. Well, we ended up getting about 17 hours of data, and this is what we ended up with. And here, you can see the black and white version of the hydrogen and the O3, and you can see that, you know, yeah, there's nebulosity here, and it's the HA is in an arc, and the O3 is a much fainter signal, but it's also in an arc. And this ended up being one of these cataclysmic variable stars. So I ended up sending this to my friend Dana Patrick, who discovered this, and Howard Bond got a hold of it, and he said, man, that's a pretty cool image. So as you would thought, we put our talents together, and here's the paper that was written about SY Cancri. And it included myself, Dana, Peter, beautiful image also that he did, and then the guy that originally found it, you know, or originally imaged it, which was David Elmore. So basically, what this is showing is this arc is kind of in the direction of the proper motion of the star. You can see the arrow down here showing the proper motion. It's almost going towards the west. You know, this type of image, east is to the left, north is up, and west is to the right. And the star is moving in that direction and producing this arc-shaped bow shock. And yeah, so what is really causing this? I think, you know, if you read through this paper, which you can find online, the real answer from the professionals is, you know, it's probably the stars just happens to be moving through an area of gas in that region of space, and it's ionizing that gas, and you're seeing that ionization as this nebula. So this is one of the few, you know, that had been discovered up to that point. And you know, being able to produce an image like this with amateur type equipment to help the professional community figure out what's going on was kind of cool. So yeah, so this was SY Cancri. All right, so the next one I'd like to talk about is this star called LS Pegasi. And the paper that was written about this was we actually imaged two different stars, and from three or actually 5 different systems, 3 amateurs, myself, Peter, and Eric Coles. and produced imagery for this paper. But LS Pegasi was a cataclysmic variable in Pegasus. It's around magnitude 12 to 13. The interesting thing was that this star had been studied for about 40 years, and it had an extensive history of all these different wavelength type studies. And it was actually discovered as a variable back in 1935. So this was not an unknown star by any chance. But it just sat there for like the next 50 years and nobody did anything with it. So again, back in 2020, my friend Dana discovered that there was this faint nebula near this star. And he found this on this survey called the VTSS, Virginia Tech Spectral Lines Survey. And, you know, he noticed that within this nebula, that the star was there, and he thought, you know what, I wonder if, because Dana's more of a planetary nebula guy, but he thought, you know, this really doesn't have the right stuff. So he actually turned to my friend Peter Goodhue to get some other HANO3 data on it with his 2 refractors in 2020. And he suggested this to Howard Bond, that, hey, here's another one of these stars that it's a cataclysmic variable. It looks like it has a nebula with it. So my friend Calvin and I, we took exposures using the DR350 in Texas in September. And I used my system at home, my 6-inch refractor at home, for my home skies from October to December of last year. And we ended up with about 96 hours worth of data between Peter's images, my stuff, and the other stuff out in Texas. So we're able to put together an image of LS Pegasi. Here's just the HA image. This is a 78 hours of H alpha, and you can see it looks kind of goofy because there's multiple images that were put together here. You can see kind of some artifacts and stuff from the different systems, but that was the HA image we got, and we thought, oh, this is kind of cool. Here is this nebula that really no one has ever seen before. It's around one of these cataclysmic variable stars. So we spent some time on it, and we put this together the same way. Sort of is like an HOO image with RGB stars. Oh, let me mention here, this is the oxygen 3 image. And this particular one did not have a real strong signal in 03. Now, this isn't a lot of time, but we did image this again this year in 03, and really didn't change all that much. So there's a little bit of 03 around the star, which is here. This is the star itself, and this is the 03 signal around it. You may think that there's a little signal here, but this is more of a reflection of the filter than anything else up in this area. But, you know, it was kind of it was an interesting deal again. And when we put the color image together, we ended up with this. You can see that this is the star here, this white star here. And I bet you can actually guess by looking at this what the proper motion of this star is. And if you think it's off to the left in this direction, you'd be correct. So we have this bow-shaped arc here. It actually hooks around a little bit, but it's kind of in an arc. That's the bow shock. In this case, we didn't have a lot of oxygen signal, but it's there. There's a little bit. There's some dust up in this area here. This is just molecular dust over here, and of course a lot of galaxies in the background. And yeah, this was the final color image of that, and this is the first time anybody had seen this nebula around LS Pegasi. And you know, this thing was known for 50 years. So why no one had discovered this, we don't know. But anyways, so this is the first image. That just shows you the directions, and again, here's the proper motion of this star. So yeah, so it's sort of the same thing as SY Cancri, in the sense that you have a star that's moving through space fairly rapidly, and it's creating this arc of oxygen and hydrogen. And yeah, so this was LS Pegasi. And here's a wide field view of what it looked like. This was from the DR350 in Texas. This is just doesn't combine all the same signal, but this is basically an HOO image. You can see the arc here, and you can see a lot of the molecular dust in the background and a lot of the other stuff. So this is more of a wide field shot. And to put this together, we took this data and just cropped it down. What we found, working with multiple different systems, different fields of view, is you're almost limited to, you want to take the narrowest system. So in this case, it was Peter's narrow view that covered about this area, and you basically match all the images to that side and combine them all together to get the benefit of the extra signal from the other shots to get a much better signal to noise ratio in the end. So, but yeah, so this is what a wide field shot was. And so that was number one for this paper. So the other one was this star called, I guess I call it ASASSN-V or ASASSN-V. It also goes by this designation of this J205457, which is basically the RA and DEC coordinates, is basically what you're seeing there. And this is from a survey. So the survey is the All Sky Automated Survey for Supernova. That's what ASASSN stands for. And this was a newly discovered CV star in Cygnus, discovered in 2020, so not too long ago. When this was discovered, Howard Bond, the professional astronomer that we worked with, he examined some of the discovery images of this, and he found that, hey, there was some nebulosity here. So he suggested this star to us, the amateurs, that maybe we could provide him some imagery of this. So, I worked again with Peter, and this time we got Eric involved with his scope out in California. And we used 5 different systems to get a bunch of time on this star, 144 hours worth of time during August and September of last year. And we put together this image of what this star looked like, and lo and behold, here's the HA shot. This is 90 hours, or a little bit more than 90 hours, and you see this arc again here in the sky. This is arc. Of course, this is starless, right? And you can see a lot more detail without all the stars in here, but there's this arc, and it's actually, this one had actually a circle around it, and yeah, it was very, very interesting. It was very similar to the other 2 or 3. And if you looked at this, what would your guess be at which way this star is actually moving? By looking at this arc right here. Well, you guessed this way, you're right. That's the way that star's proper motion is. So here we have another star that is very similar to the other ones that we just looked at. And yeah, so this is 91 hours. Here's just a zoom in on that, where you can see that it's got this oval ring around it. And this is the west side over here. There's a brighter area to the west here, but there's this arc right in here. And this is the full resolution shot in HA. And yeah, we thought, oh, this is another one of these really cool objects. So we put together the color image on this. And we've also found, here's the O3 shot, actually. The O3 has this kind of like this triangle wedge shaped looking arc. This is the bow shock in O3, and it's got this really brighter area of O3 on the northwestern edge of it. Again, west is to the right here. So, this is in the direction of the proper motion of the star, which is going off this way. The 03 shot was 42 hours. We probably should have shot more on that, but we're limited with time. Even with the 5 different systems we had running, and I don't know what we would have found if we just had one. Like say myself or Eric or Peter had just shot this thing with that. It really took a lot of extra effort and time to really bring out the signal like you see here. So that's the 03. And then putting it all together, we get an image that looks like this, which is with the stars. You can see a lot of the hydrogen background. You see a lot of dust, molecular dust over here, molecular dust up in this area. This is a combined image, which mapped red to hydrogen alpha, blue-green to oxygen 3, but it also included quite a bit of RGB data from, in this view here, the RGB data came from the high altitude system we have in Texas, the DR350. And yeah, so we were able to produce this really cool image of ASASSN-V. And the star is right there. And let's take a look and see what, there's the proper motion of this star. So it's moving this way. It's producing this bow shock. And yeah, this was the first color image that anybody had basically seen at this depth of this actual object. So this was a paper that included both of these, that LS Pegasi and ASASSN-V. And the takeaway from the professionals on both of these was, hey, us as amateurs, we have some pretty decent equipment these days. And even though our scopes are relatively small, when it comes to what the professionals are used to using, with our great optics and our modern cameras, we can image very, very faint objects, very faint surface brightness nebula. And it really kind of blew them away. These types of images obviously are really helpful to professionals. Just think of what you folks out there that are watching this use. You're using some really interesting equipment, really good equipment compared to 15 or 20 years ago. I mean, what we can do these days with these low noise cameras is pretty incredible. They also recognize that these were the first color images of these nebula around 3 of these NLV type cataclysmic variable stars. And there's only 5 of these that are known. And these typically have the bow shocks that are moving in the direction of the proper motion of the star. And, the final suggestion was that maybe these are just because of chance encounters with these interstellar gas clouds. These stars are just moving through space. They kind of encounter these areas of these gas clouds, and they end up ionizing them. And we see that ionization as the nebula that we're looking at in our images. So that was kind of neat. All right, so a couple more to show you guys here. This was just the paper. This was in the Astronomical Journal, and this was just published a few months ago in August, August of 2025. But yeah, you guys can find that if you want to go read the actual paper. This is just the cover of it. There's another one I want to talk about. A story here with this one too. This is a cataclysmic variable called ASASSN-19DS. So this is an interesting story. So this star is a 15th magnitude binary that's really, really far south in Antlia, -40 Dec. And it's what they call a Z camelopardalis type cataclysmic variable. and it's kind of a dwarf novae type CV star. So my friend Dana asked me in November last year, hey, I've got another one that I sort of found. What do you think? Can you kind of shoot this one? And I looked at it and I'm like, wow, this one is really far south. I mean, I don't know if I definitely cannot do this from home. But I told him, I said, listen, Dana, I'm going to the Winter Star Party, and I think I can reach it from down there in the Keys. I think it'll be about 25 degrees above the horizon. And so I said, I'll do what I can. So on my way down there, I stopped at a friend's property, which is near Lake Okeechobee. And this friend of mine, he has star parties every year. And there was another individual there that I've known for a while, and his name was Daniel. Daniel Stern. And I knew Daniel had 2 telescopes in Chile. So I started to talk to Daniel about this. I said, Daniel, look, Dana sent me this object and it's way far south. How would you like to try to shoot this from you using your scopes in Chile? And I'm going to try it from the Keys, but all I have is my little 80 millimeter refractor, and it's going to be really low. It's going to be way down low in the soup, but I'm going to try and see what I can do. And he thought, you know what? Yeah, I'm going to give it. So I gave Daniel all the scoop about this star. And I told Dana, I said, listen, I have a friend who's going to image this. And so we did it. So here's the image that I shot. I did this at the Winter Star Party with a little 80 millimeter refractor. So you don't need a gigantic telescope to do something like this. I used a color camera with a dual narrowband filter. So I have an ASI 2600 MC Pro on this scope and a 5 nanometer Amplia ALPT filter, HA03. This is 10 hours of exposure, and the star was averaging about 23 degrees altitude, I guess. We ended up having a couple of good nights, and I could see down low to the horizon. I ended up sending this image when I got back to Howard Bond, and he was like, oh, you've definitely confirmed that there's HA around this star. The hash marks here are showing you where the star is. Yeah, it's got some HA, especially on the northeast side. It's brighter up here. And yeah, that's from my little 80 millimeter scope. So just because you guys, somebody is using a small scope in their backyard, that does not mean you can't make these discovery type images, because this was the first one taken of this star. And it's just a little tiny telescope. So here's a 22-hour exposure from the CDK 24 inch Chile Daniel scope. And I didn't enhance this much, but you can see the HA here. This is the star right here. It's a little more zoomed in. You can see. So here's my 80 millimeter. You got the 2 stars with the 19DS right here in the middle. And Daniel's shows a little more resolution, of course, more background stars. And this was the HA nebulosity that he found there. So I was like, oh, okay. So he's got it. And we put that together with the 03. Here's the 03 shot that he did, 25 hours. And it showed a really interesting signature where we have this kind of like this dual lobed look to it, where you have an arc of 03 down here and another arc up top. So it's got some dual lobe type structure to this actual star. And yeah, this would really surprise the heck out of us. So we put this together into a color image, and we came out with something that looks like this. This is Daniel's data that he took from Chile, where we have this dual lobed 03 type structure with HA in here. There's actually HA underneath here. We just decided to kind of show the 03 more, but it's the HA's under there. And yeah, so this was the actual image, and the first image ever taken of this star showing this nebulosity. And, it just so happened that, I happened to be going to the Winter Star Party. I happened to stop at this spot on the way down. I happened to run into my friend Daniel that had a scope in Chile, that we ended up with this. So this was really interesting. And Howard Bond was excited and enthused about this. And, he was just ecstatic. And that ended up with this paper here. Where Daniel had provided most of the information, but Howard actually published that initial picture that I took, which was this one, in the paper. So I guess my point would be, just because you have a small telescope, you can still do a lot of good stuff with that small telescope. So there's the paper. So that was, I think, this was just published in September, again, in the Astronomical Journal. And so now we have, I think, 1, 2, 3, 4. There was 5 known. The thing with this one is, this one possibly could be a planetary nebula. We're not, Howard wasn't quite sure about this, but it's a cataclysmic variable with an interesting nebula around it. So it was another one of these stars that no one really knew anything about, and hopefully, we're able to help the professionals figure out, what's really going on with this. So, all right, so that's really the gist of my talk. But I want to show you guys some first images. These are the first images that you will see of this star. This isn't published yet, but this is a star around this object called STDR 90. This is in Vulpecula. The star is FY Vulpecula. And sure enough, this star is a cataclysmic variable, and it's one that we've been working on over the last couple months. This isn't quite published yet, but I think this is coming here soon. Here again, we have this oxygen 3 arc in the direction, proper motion of the star. You can see here with the HA around it. The HA shock wave is a little bit weaker here, but you can see it's kind of, you have this little arc here, a really, really faint portion of it here, and then a little bit here. This is hot off the press, and this is the first. You guys are the first ones, other than I did show this at the Okie-Tex Star Party. So you're number 2 of seeing this nebula up there. So it's kind of cool. This one's up and coming. And there's some other ones that we've been working on. This is a really interesting object called STDR object number 14. This is a little different though. It's got this arc that we noticed, but it's also got something different. It's got this ring actually around the star. This is the HA shot. This is just the HA that I took from home. This does not include other data that Peter has taken, and I don't remember quite if Eric has taken data on this. I think he did. But anyway, so this is we're not sure what this one is, but it's a really interesting object, just to say the least. And this other object called STDR4. Again, we have a bow shock here. We have we think it's a cataclysmic variable here. It's got a proper motion in this direction. The difference here, though, is there's no oxygen 3. It's mainly just hydrogen alpha. So these objects are probably ones that are going to be up and coming here in the next months, maybe 4 to 6 months. There may be something written about these, and it's kind of exciting times. So I think that's probably it. And I think right about 50 minutes. So again, that's what I wanted to show you guys. Thanks so much. I wanted to just mention that as an amateur astrophotographer, shoot some of those really faint things. Put those things out there. Spend some time on them. You'll be surprised, and you may get the attention of someone that you didn't even expect. and in my case, I got the attention of Howard Bond, and so we've developed this great relationship between several amateur astro imagers now, and we produce imagery for these guys, and shoot that really faint stuff. I guess I'll stomp on that again. So thanks so much, and I'm gonna get out of sharing my screen, and I'm gonna go back to group here. Oh, are we back?
No, we got the infinity screen.
Yeah, what do I have?
In the upper right corner is a stop presenting button.
Oh, there we go.
Stop
Sorry.
presenting.
Yeah, got it. Okay, so anyways, yeah, that's a fun amateur professional collab story, I guess I'd call it, and I'd be happy to take anybody's questions if you have some out there.
John, can I add one thing here? I think that,
yeah,
if you're a professional astronomer and you want telescope time, you write a grant, you're in competition with 100 other people, and we have the luxury of, hey, can you shoot that tonight? Yeah, I can shoot you 8 hours of that tonight. I mean, that has to be fantastic, and we have hundreds of people out there that could do that if they were interested, because we control our telescope and we can shoot whatever we want.
That's a great point.
Okay. John, we've got some others coming in from the chat columns, and we remind everybody that would like to ask a question, just go ahead, type it into the chat, and we'll try to get through it. Okay. Steven 2615 wants to know, that list you were talking about that your buddy gave you of secret dark objects.
Yeah.
Is it publicly available?
It is not publicly available as far as I know, but I don't think there's any issue with sharing that list. It's just a list that he put together based on the declination of my house. So it's kind of tweaked to where I am, but people can email me, and I'm happy to share it.
What's your latitude?
I'm at 30 degrees north.
Okay, well, I think a lot of people could benefit from that. A lot of amateur astronomers could benefit from that.
Yeah. So my email is asro8042@gmail.com.
And perhaps you could post that in the comments to the YouTube when the YouTube gets out. Okay, or not your email. Just post where one could find that list or something.
Good point.
Okay. Edward Brownman wanted to know, can you calculate the star velocity by using the shape of the bow waves?
Oh, that's a good point. But I would leave that to the professionals. I have no clue how they figure that out. I'm sure there's probably a way to do it. But again, I'm more of an amateur. I'm an imager. I produce the imagery.
Mm-hmm.
I don't know the physics behind it. Molly may know more of the physics behind it, I think, than I would. But I know that they do studies on using I'm thinking of the term where they can determine the actual distance of the star using
radial velocity.
Yes,
or parallax.
Parallax.
Yeah.
Yesterday at nightfall, Adam Block did a presentation of the new program, or the new, which is a script, I assume, in PixInsight, where the HR diagram.
Yep.
And part of the well, why don't you tell them what the HR shows you? And it does show proper motion and speed. How does it get that information? Could you go ahead and tell folks that?
Yeah, so if you download, you go to cosmicphotons.com. That's Cranfield put that together with Adam. And other than producing the HR diagram, which basically shows you, where the stars in your image, like a globular cluster, how those stars fit according to all the other stars in the sky. You can actually use the Gaia catalog in PixInsight, and it will produce the proper motions of all the stars and put vectors on each star that you can look at, and the length of the vector is the speed of the proper motion, actually.
Mhm.
So basically what you would do is it gives you an option to type in, what do you want to look at in the sense of years. So if you put in like, okay, where's the star going to be in 500 years or 1,000 years, it'll put a proper motion vector line on there for you, so you can see, that star along with the other ones. You can see the size of those lines, which basically tell you how fast they're actually moving.
And all that information came from satellite surveys
Yep.
of where
Yep.
the stars are and how they've
Yep.
changed since last month, that kind of thing.
Yep, the Gaia
Yep. That's the Gaia catalog, right? So all that information is available for amateur astronomers and astroimagers by just using PixInsight.
Absolutely.
It's pretty much there. Okay. Bow waves, bow shock. Are we to believe that the gas up there is acting like a liquid, and just as a ship moving through the sea can push water in front of it? Is it a lot trickier than that? I mean, why would there be a blue O3 showing in this arc when we can't see the hydrogen alpha doing the same thing, acting the same way? It's the same gas, right? You know the physics of that?
Well, no, I don't know the physics, but some of the images actually do show that, show the HA and the O3 in that arc.
Okay.
So if you read through the actual papers, the overall thought is that these stars are moving through space, and if they happen to run across, they produce UV and different types of radiation, right? And when they run into this gas, is the thought that it ionizes the gas, and the color of the gas tells you what type of gas it is, right? So the red is the HA, O3 is this blue-green type color, and there could be other types of gas, but we're only using HA and O3 filters in this case. But not to say that there isn't other types of gas there also. But the thought is that the star is ionizing the gas that happens to be, there. You wouldn't see it otherwise until this star comes along, and that intense UV radiation ionizes that gas and makes it glow.
The gas is not coming from the star that's moving through. The
yes,
star is just lighting it up.
Yeah, the gas is already there. The star is lighting it up. That's the thought. If you really read the papers really closely to the end. At least that's the thought right now from the professional guys. But yeah.
Okay. Stephen V wants to know what focal length you're shooting. Although I think some of the images you're showing us are coming from a variety of telescopes, right?
So we had 5 different telescopes on one of those images, and I'm shooting at 1,200 millimeters. Peter Goodhue has a scope, I think 2 of them at 1,200. The one in Texas is a little over 1,000, the DR350, and then Eric's scope is more like 3,000, I believe, right, Eric? 3,000?
4,000.
Okay, 4,000. So yeah, the focal lengths are, Eric is giving us this nice high resolution stuff, and then we're using the lower focal length, wider field of view, but we're taking all that and putting it all together in a single image.
Yeah, and actually the wider focal length, you get more photons per pixel, so it lights it up a little better.
And you were picking it up with the standard 80 millimeter refractor, with the lights over Cuba and all that other stuff, right? So that's not the equipment. It's the skill of Jon Talbot.
You don't need a telescope. Everybody that's listening to this that does astrophotography has a telescope and a camera that can be used for this type of stuff.
You don't have to be a professional. You have a telescope. You have an opportunity to collect photons.
Right.
That's really all it's needed.
And you need to have that break. You need to find that somebody out there, that professional that wants to utilize your information. And the way I found to do it was I just shot this really, really faint stuff. And That wasn't the only email I got, though. I got other ones from other researchers too. So, it gets the attention of that community because, like Eric mentioned, they don't have time on professional telescopes. Us amateurs, we have plenty of time and we have the equipment, and we can produce almost as good results as the professional guys can. It may take us 40 or 50 hours versus 2 hours with this big 10-meter telescope, but we have time.
But they may have to wait 5 years to get time on the 10-meter telescope.
That's right, but we can do this from our backyard. We don't have to be in a dark sky to do this.
We can do it tonight, actually, John.
Mine is actually going right now as we speak on one of these stars. So.
Well, one of us from the Astro Imaging Channel, I was supposed to see the Molly or Jaime or Linda, provided a link to Cosmic Photons where you can download the script that we were talking about, the Hertzsprung-Russell diagram, where you can chart all the stars in a given image and find their proper motion. Adam was using it yesterday with globular clusters, and you can see which stars belong to the globular cluster by their proper motion compared to the foreground stars or something like that, which have completely different speeds and everything else, according to the Gaia catalog.
Yeah.
So also a reminder, if you do download the Gaia catalog, download the complete set.
Yeah.
It's a bit large rather than the abbreviated set.
Yeah, and it shows where all those stars fit on the main sequence. That's the important thing, with these globular clusters. You've got a main sequence, and it shows exactly where those stars are. That was the really cool thing about the age.
You can tell the age of the globular cluster. You can what developments have happened to the stars through their lives and things like that.
Yeah.
And an interesting part of the calculation is in the globular clusters, they're all essentially at the same distance.
Mm-hmm. Okay, that's. I think that we've got everything off the.
I think we're all set.
There was one other question. Otto asked if all of these stars had a bow shock, all of these cataclysmic variables.
Well, from what I understand right now, there is 6 or 7 of them. When we first started, there was 5 of them known, and now we've added 3 or 4 more, so maybe 9 of them are known. Whether they all have them, I don't think so, but some of them do for sure because we're seeing it. I think we've had 1 or 2 duds that didn't have anything, but so the answer would be no, not all of them, but obviously some of them do, and we're trying to figure out which ones those are.
And you're focusing on cataclysmic variables. Aren't there just stars that are not cataclysmic variables that would be moving through an area of nebulosity that would do essentially the same thing, create a bow wave?
Well, possibly, but the thing with these cataclysmic variables is here you have a white dwarf and you have another, like a feeder star that's rotating around that white dwarf that is, providing hydrogen and energy onto that white dwarf, right? And which is, a very energetic event. So that maybe has something to do with it also, versus a normal star that maybe doesn't have, another companion in orbit around it that's feeding off it in a sense. So yeah, I don't know, but these are very energetic stars for sure.
Okay,
I think we're all set. John, thanks very much for a very interesting presentation. And I'm sure we're all going to be looking for little bow shocks in all our images from now on.
All right.
So, and remember everyone, come in 2 weeks and hear about all the things that can go wrong with your setups if you don't already know. Murphy's Law. And I think if we're all set, I think we're done. We can call it a good night. So
All righty.
Good night, everyone. And John, hang on for a few minutes. I got a couple of questions for you.
Good night, all.
Good
Good night.
night.